Hey, this is Kenneth, and today, let's keep talking about Digipeaters. Last time I went through excruciating detail for the audio interface between a mobile radio and a terminal node controller. Last time I used a GM300. For this project, I'm going to be using a CDM750, which is about 2 generations older or newer than the GM300. These are great radios. They're 4-channel. They come in both 1 to 25 watt and 25 to 45 watt models. This is one of the 25 watt models. So if you look there, the model is the AAM25KHC9AA1AN. So main thing is it's only 4 channels, but since we're using this for APRS, we only really need 1 channel. So I buy these in bulk on eBay and just sit down for an evening and do alignments on several of them so I can have lots of packet radios. So last time we talked about this radio to the terminal node controller, and for a standalone Digipeater, that you can get away with just using this, right? In this case, we have a PK88 from AEA. I've seen this one set up as a standalone Digipeater. Many of the other terminal node controllers can also be used as standalone Digipeters. But it's a bit difficult because the APRS spec is kind of a moving target, and so inevitably the terminal node controllers don't quite behave the way that you would want in a modern network, and so you will oftentimes see these acting just as the KISS modem with a serial port over to a computer running a Digipeater software package such as APRX, which I'm the maintainer of. You will also need a computer for when you want to be an internet gateway instead of or in addition to being a Digipeater, right? And so on the internet gateway side, radio signals come into here, the audio signals are decoded in the TNC, the KISS serial stream goes to a computer, which translates these to the internet connection, which would come out from there. For this build, as far as the computer that we're using, I'm using what's called a Qotom Q190S-S01. I just found this company a few months ago, and I've been playing around with a few of their different products. They're the Mini, Nano, Pico, ITX motherboards. They're pretty slick. They run on 12 volts with a pretty wide range, and you can buy them as these bare-bone PCs for sub $200. So all you need then is a stick of RAM and some sort of storage media. They have SATA ports on board and typically also mSATA, right? So we've got a 120 gigabyte mSATA card. This was kind of the last generation flash storage. A lot of laptops now are using what are called NV2 flash, which looks very similar but is somehow different. And this uses the standard mPCIe slot connector, which I think is different, so you can't interchange mPCIe cards with mSATA storage drives. So this goes into the mSATA port on the computer. This goes in the RAM stick slot. The Qotoms have typically one DDR3 RAM slot and support up to typically about 8 gigabytes. This is a 2 gigabyte stick I had laying around in my apartment, which is more than adequate to run a command line only version of Debian or any other Linux distro, and APRX. APRX is extremely lightweight. It is known to be run on like Wi-Fi routers, right? So the WRT54G from Linksys has run APRX. I don't recommend it, but people have done it. So let's look at the actual Qotom itself, right? So this is one of their lowest end models. It's got a Intel Celeron processor in it, quad core 2 gigahertz. So it is got plenty of horsepower for what we're asking for from it. It comes in a brown plain cardboard box like this. I wrote the model number on it just for my own sake. And as it comes out of the box, that's it. So on the back we've got 2.5 millimeter 12 volt barrel, HDMI, VGA, 2 NICs, although on this model these happen to be Realtek NICs. On their higher end Q190 G4 model that actually has 4 NICs that are actually Intel, which is preferable when you're doing weird stuff like VLAN tagging or really want to get high performance out of it. Since this is just going to, so I use the G4 as a router. Since this is just an end node, we're only going to need one of these 2 ports, and I don't really care how squirrely the drivers are for it. Headphone jack. Looking on the other side, we've got microphone, 1 USB 3 and 3 USB 2, RS-232, and a power button. I haven't confirmed yet if this specific model supports auto power on. I know that the G4 one does. So, and for a Digipeater, we definitely want it to automatically turn on when it loses power without having to come press the power button. So we're going to find out if that works or not. So this is it, right? It's got it's kind of a real nice anodized aluminum case. The case itself is in 4 pieces. We'll be taking that apart. It also comes with rubber feet, so if you're using this as just a desktop model, it has 4 locations for rubber feet. It has a power supply for it with the 2.5mm barrel. In the final application, all of this stuff is going to be running off of one like Astron power supply, and so I'll just be creating a 2.5mm 2 Anderson power pole adapter, so all this stuff can plug into a power pole power strip. IAC cable, bag of screws. In this case, since this case isn't intended to be used with a SATA hard drive, it doesn't have hard drive screws. It only has 8 screws required for the VESA monitor mount. And so this actually has the screw holes in the back so that you can, with this plate, mount it on the back of your monitor, which would make for a really clean, low power workstation setup, right? And so if you just wanted to do basic web browsing and stuff, this would actually be a pretty slick device for it. Since the processor in here is only a 10-watt package, so the whole thing only pulls 15-20 watts. I think the spec says that it's 23 max. So that's kind of the computer we're playing with today. We'll see how well that works out. I guess we'll need that. Let's open it up and look inside, and then we'll see if we can get Linux installed on it and get APRX running. I think we're going to walk through the whole thing here, so strap in. We're about to have some fun. Alright, so looking at the Qotom Q190S, to get the case open to install our hard drive and RAM, we first have to take 2 screws off of each side here, which I've already done. Getting this top part off is a bit sticky, as they've got some gap filler in there that makes it feel like it doesn't want to come, but it does. Use a OSHA approved pry bar here and just kind of nurse the thing out. Ta-da! Alright, so there's our motherboard. So here's the mSATA spot. Here's your MPCIe slot here, so you could put a Wi-Fi card here, and it has 2 mounts for Wi-Fi antennas, right? So you can have Wi-Fi outside of it. Processor is underneath this passive heatsink, which then comes with gap filler on the outer case, right? And so you could run it with with the top off like this if you needed the space for like a SATA hard drive or something, since there really isn't space in here for a SATA hard drive, but this couples onto there, so the case is self-cooled with no fan. Over here we've got a SATA port and Qotom's little 4-pin power plug that comes out to a SATA 15-pin. That cable didn't come with this kit, but it comes with their ones that are actually meant to have a SATA port or a SATA drive used with it. All sorts of extra I/O headers like most motherboards. So we've got 3 more serial RS-232 serial ports, another USB port, front panel audio, couple jumpers for like the power LED and button. So if you wanted to remote those, you could. And a 0.1 inch header right there for DC power if you didn't want to use the barrel jack on the actual faceplate. So we can install the mSATA drive. Once I get the packaging open. I said once I got the packaging open. There we go. Alright, so there's our mSATA drive. Comes with documentation, which you should clearly very carefully read. And then it would go in there. So let's take this screw out. And this just seats in that connector, which is indistinguishable from mPCIe, but is, I believe, totally different. So like on some motherboards, they'll have two, the ones that support full-length PCIe cards instead of the only half-length one that you have here. You'll need to be careful about which one's the mSATA port and which one's the mPCIe port, because I don't think they're interchangeable, which is probably part of the reason why this storage standard was so short-lived. That being said, you'll notice that there's no RAM port on here because it's actually underneath there. So we have to get the case pretty much all the way apart. This case is actually 4 pieces. So we've got the top anodized part, 2 more anodized parts that are the faceplate, and then an actual, I believe it's plastic base. So we're gonna have to take all the screws out. Yeah, I think you do have to take all the screws out because the 4 screws holding the motherboard in, it's also wedged in here. So maybe we only need to take one of the 2 face plates off. But in any case, the motherboard is definitely coming out. Now when you take these apart, you want to be careful. The power button on the front plate is kind of just free floating between the contact switch and the face plate. And so if you just, when we pull this face plate off, that power button is going to fly out. So you don't want to lose that. That would be sad. Is it doesn't quite want to come for me yet. There we go. Oh, and like I said, stuff flying everywhere. Cool. So yeah, so there's the power button. We have managed to not lose any screws. And then looking on the underside of the motherboard, we've got, these are the heatsink screws holding the heatsink on, so if you wanted to replace this, that's where you would attack it. And then there is our single DDR slot. So we'll take this 2 GB stick, which I just had laying around, and I guess we will eventually find out if it works or not. And we'll slot that in just like so. There we go. So now we can hook up a monitor to this, power it up, and install Linux. So let me go pull out my monitor and keyboard and we'll see if we can get this thing cooking. Alright, now that we've got the mSATA hard drive and the 2 GB of RAM installed underneath the motherboard here, I've got it hooked up to an HDMI monitor with a USB keyboard and a network drive. And the next step is going to be configure the BIOS how we want it to automatically turn on after power loss, right? So that if at the Digipeater site we lose power and we get power back, I want the Digipeater to come back. So we'll need to configure that in the BIOS, and then we'll need to install Linux, in this case from a USB key. I typically install Linux on my home network over PXE, which is a nice net boot protocol, so I can actually tell the computer boot off the network and it'll have a menu about which OS I want to install out of the ones I typically use. I've had some difficulty with the Qotoms getting them to talk PXE on my network, and my router recently blew up and I don't have a PXE server at the moment until I rebuild it because, you know, backups are a thing. So we're just going to use the USB key here to install Debian and Jessie. That being said, installing Linux is a pretty well documented process online, so I'm just going to kind of rush through it. The main thing is you need some sort of Linux running on it. You can, for APRX, I post pre-built binaries for x86 on Ubuntu, but you should be able to use those with Debian, and compiling APRX from source is very, very easy. And so that's actually what we're going to be doing here. But first, let's get the BIOS set up. So press the power button and mash F11. Comes up with a boot menu about booting off of the SSD or entering setup. So we want to enter setup. Real standard American BIOS here. So we want to go over to advanced ACPI settings. Restore AC power loss. It's currently power off. We want to power on, right? So anytime that it loses power and gains power again, it will immediately turn on. Other than that, we, wake up alarm, LAN wake up. If you wanted to do LAN boot or something, you could, but I just want this thing always on. So save and exit. And there we go. All right, next, I took a USB flash drive. I just imaged the Debian install disk on here. Again, a documented thing online. I'll link to some tutorial on it. So I'll plug this in, and then we'll install Linux and come back after that. Alright, so there we go. Kind of uneventful Debian install. It did ask for the Realtek drivers at the beginning since it didn't have the firmware for them. I just declined that option and it ran with whatever failback it had, which was good enough for this. So at this point, if I really wanted to get the most out of these gigabit NICs, I should go hunt down the firmware online or from repositories. At this point, let's switch to a different camera angle and I'll walk you through the software setup in Linux as far as setting up a basic APRX Digipeater. Alright, so we've got Linux installed on this device, which I'm calling Balder, to match with my apartment's Norse gods theme. We're switching over to my laptop here to be able to screen capture this. So this is a PuTTY SSH session logging into Kenneth at Balder, right? So we'll give the password here. And here we are. All right, so the first thing we want to do on our new system is update the package manager. Since I installed Debian without a root password, the sudo command gets enabled. And so from my user account, I can then instead just say sudo apt-get. I can just, so we did update, we can now say upgrade. This will probably come out with nothing, right? So now we want to install various useful utilities, right? So new system, I like to install vim, dstat, screen. We're going to need git, we're going to need build essentials. We're going to need dev helper. We're going to need libssl. That should be about it. We can double check the build dependencies for APRX on the APRX repo under install. I've got a little list at the bottom here. So build essential, dev helper, libssl, git. Yeah, that'll be fine. All right, so we'll run that. And we'll say, yeah, we want all that stuff. So we'll download it. That'll take a second. So we're gonna be compiling APRX from source here, but you can just download a deb and do an install on it. I like to do it from the Git repo. primarily because I'm the developer for APRX, so I do this all the time. But I tend to have various little patches hanging out in the repository that haven't made it into a tagged release yet. So if you're willing to deal with the risk of possibly getting a patch that's a little bit half baked and not quite right yet, there are some advantages to that. So looking at the repo itself, so the repo is linked from the main APRX website, and over here you can say clone, and there is the repository URL for it. So now I like to make a directory called source, and then we will clone the repository. So that's going to download all of the various objects in the Git repository. So locally, you'll actually have the complete history of the Git development, which is kind of a fent of the APRX development, which is a great property of Git and one of the many reasons why I love it. So you can see there's now this APRX folder. In here, we've got everything. So the default configuration tends to be pretty sane. So we'll configure it. And then since we're running this on a Debian system, there are advantages. So typically your typical pattern here would be you would do a configure, you would do you would type make to compile it, and then you would do like a make, or like a sudo make install to install it on your local system. And that does work, but APRX for that gives you a bare, it puts the executable in and lets you run it. Since we're on a Debian system, if you make the Debian package, it will actually give you a deb file as the output, which you can then churn through your package manager, and has the added advantage that it pulls in a few more kind of Debian specific environment stuff, particularly for log rotate files and a system5 init file for starting it, and all of those sorts of things. So there are certainly some advantages. The compilation for APRX here doesn't take that long, particularly on a nice Celeron processor like this. It does get a little tedious on Raspberry Pis or something, but for a number of reasons, I don't use the Raspberry Pi. So something to note here, every time you build APRX, it comes with a version number. So the latest tagged release will be APRX 2.9.0. I have it set up so that in the repository, when you compile it from the repository, it automatically appends any information about how much further along we are from the latest tagged release. So you can see that we've had 19 patches since 2.9. So really, it's about time for me to do a 2.9.1 release, and with the kind of the beginning of the git sum, right? So if we did git log here, we can see that the latest commit was this checksum done on Sunday, December 18th at 2 o'clock in the afternoon. And apparently I made an update to the manual, which was updated contact info for maintainer, which is, me. So apparently, I found a place where my email address should have been, and it wasn't, right? So, and you can scroll through this all the way down, and it's got everything there. But, so we've compiled this Debian. So if we change directory to the parent directory, this new deb file shows up right there, right? And so if we do a dpackage install APRX, and I'm trying to get my tab completion there. If we install it, it's going to churn through it. Now, apparently the most recent versions of Debian and Ubuntu do have APRX in the universe repository packages thing. It's a pretty out of date version of it. I've been working with the Debian ham guys to try and update it, but I would not recommend doing that. It was the last release Matti did before I took over, more than 2 years ago, I guess at this point. But cool. So now we've got APRX installed, and so, really? Oh. I thought I had, Yeah, there we go. So apparently I don't have my environment set up right for. So one thing to notice, one thing that kind of annoys me about Debian is these sbin directories aren't added to regular users' paths, which is why as a regular user you can't find things like ifconfig, because ifconfig is a quote root user configuration tool or anything. But anyways, so now that we've installed it, in etc, there is we can't really see it, but there is a APRX config file, right? And so this is in this file, this is kind of how you set up APRX. APRX is a tremendously flexible system, and I can't encourage you enough to go to the APRX website and read the manual right here, first link. So this manual will kind of walk you through all of, kind of basic stuff for how to change various lines in it. It doesn't give a good intro yet on when you would want to make specific decisions, but that's so it is. So the main thing is here, we're going to be just working our way through this. So for this Digipeater, we need to make a decision, right? We need to decide, well, are we going to be a fill-in low-level Digipeater? Are we going to be a high-level Digipeater? Is this going to be a internet gateway only? Is this going to be some sort of real involved multi-port, whatever? You need to make that decision, right? And that's a real tough call based on what the local environment and all the other parts of the network are. So we're just going to start deleting the comments, which you, of course, will be reading. First thing you encounter is this mycall definition. This is just a convenience macro that lets you set up your call sign, right? So mycall W6KDF, and then you can pick a SSID between you can either have it bare or you can have it between 1 and 15, right? So we're going to go with 14 since that's an available call sign for me. Another convenience macro here is my location. So we can sit here and define the GPS coordinates you want. And one thing to note here is latitude is in degrees and then minutes and fractions of minutes. And so there's no seconds involved in APRS GPS locations, and then longitude again is in degrees, minutes, and then fractions of minutes, right? So I'll fill that in later. APRS, this is we've now encountered the first kind of interface block. So the APRS block is how you define if you're operating as an internet gateway in the APRS block, you would define your credentials. So here you would put your passcode, which is a function of your call sign. So if no one has issued you an APRS IS password yet, you can email me, and I will email me with your call sign, and I can issue you a passcode. There's various servers that you can choose from, or these are actually groups of servers. So the server rotate.aprs2.net is just any functional APRS IS server in the world, which is about 50 to 75 of them, and that's perfectly fine. So we'll stick with that. So of course I'm leaving that blank, but you would need to come back later and update that. And at its bare minimum, that's really all you need. If you want to get additional, by default, the internet system will only send you packets from stations that you've recently iGated or messages destined to stations you've recently iGated. You can add these filters to get additional packets, but we're not really interested in that, so we'll just leave it like that. So APRS, you give your passcode, you give your server, and that's it. All right, logging, you can pretty much leave it at its default. There's nothing too profound. I kind of like to change the rflog file name to just rf.log, but this is just a personal preference thing. I haven't wanted to change that default. All right, and that's all you need for a basic setup, right? Because we're going for just a basic low-level Digipeater, iGate, RF gate sort of setup here. Now you need to define your interface, and this is where it's going to depend a lot on your specific environment. There's lots and lots of different options as far as if you have an AX25 device set up with you through the kernel, you could do that there. APRX supports several different types of KISS TNCs, KISS, XORSUM, SMAC, FlexNet. TNC2 is just kind of a bare monitor, so if you have a terminal node controller that's spewing decoded packets, you can just monitor it like this. This is not recommended. TNC2 modes tend to be a little bit hacky and kludgy, which is why APRX doesn't allow you to digipeat on TNC2, only iGate. But regardless, this block here is kind of pretty close to what I'm trying to accomplish, so we'll uncomment that one. Come on. So serial device, so this is actually going to be on TTY S0. This is a physical serial port on the computer, so it's typically TTY S0 through 3. But if you had a USB adapter, it's typically TTY USB 0. Sometimes it's TTY AMA 0. And that's just something that depends on your local environment. Baud rate, this just has to match whatever your TNC is set up for. So I typically set up my TNCs for 9600 baud just because it's what I'm used to. Then 8N1 is just the bit width of it, which really should never change. And then we're saying that this speaks KISS as opposed to any of the other ones. Since this is going to be a single interface Digipeater, we can leave the call sign as my call. Since we want to be able to digipeat and RF gate stuff, we have to specifically say we are okay with this interface being a transmitter, right? And so this is kind of a nice fail safe here, so that if you have the radio set up in some way that it wouldn't be good for it to be transmitting, either because you don't want it to, or because the power amplifier is blown out in the radio, which is real common for APRS radios since they're just kind of left over. But whatever, it's this extra step, so that if you want it to be transmitting, you have to set that up. All right, so we'll just keep deleting commented out interfaces here until we reach the beacon block, right? So the beacon block says this is how we would identify ourselves. Beacon mode, you can either choose to go on APRS, so when all these beacons, you have either go straight to the internet, go to the radio, or you can have it do both. I typically prefer to have stuff go out just the radio, since it's a real easy way to see if I've got a radio problem, right? Because I'll be able to look on the APRS FI map, and if my Digipeater is still there, I know that it's transmitting and getting picked up by some other adjacent internet gateway. If it disappears, I can know that there's some problem between APRX and the radio. The cycle size is how long you want this list of beacons to repeat, right? Because inside of this block, we can set up any number of beacons we want, and then it'll cycle through them. 20 minutes is a pretty good default, so we'll just leave it there. And so just once every 20 minutes, we'll have it do one beacon. So we'll have it do that one. Here's come on, delete that. So here's a pretty good line. This is where the my location alias that we would have defined at the top comes in real handy, because all we have to do is say myloc there. Beacon symbol, selecting the symbol is a whole ordeal. I wrote a separate article on this, but since we're a internet connected iGating Digipeater, iPound is a good symbol set to use, right? And then for comment here, we'll say that this is a, I don't know, development, a demo digi setup, whatever you want to say there. Typically you would say, oh, who knows, right? This is just the comment field. Really, if you have nothing to say, you should leave that empty, right? But we'll just say this is a demo digi. That way people can know why it pops up, right? And so then you can duplicate that line. You can set it up with different paths. You can tell APRX to execute a separate program and take the output of that. You can tell it to beacon raw stuff. I mean, it's the beacon source thing here is extremely flexible, right? And so if we wanted to have this beacon again, but with a longer path, we could do something like that, right? If we wanted it to beacon once every 10 minutes, and then every third time have it go via a hop, wide 2-1. We could do something like this, right? Cycle size 30, 2 no hop beacons, and then one hop beacon, right? Fantastic. Telemetry, that's also a thing. If you're interested in getting telemetry, APRX will produce the telemetry as far as how many packets it's receiving and how many packets it's transmitting on any of the interfaces you set it up on, which is really interesting data when you're monitoring the local channel status. And then this is where APRX really shines, is these Digipeater blocks. This is really what makes it so great, because you can build extremely flexible blocks. So in the Digipeater block, the first thing you define is your transmitter, right? And so we're going to say transmitter is, my call, because we're a single port Digipeater. But if we set up multiple different Digipeater, you can actually set up multiple different ported Digipeaters that are either cross-banded together or separate independent entities or whatever you want, all in the single instance of APRX running. In this case, my call is the only, this alias for W6KWF-14 is really the only one we got, so that's all we need. The rate limit and the source rate limit, this lets you actually define minute averages on the channel. And so this is kind of pulls in network quality of service concepts into APRS. So this says that we can, on the transmitter for this Digipeater, APRX is only allowed to average 60 packets per minute and never burst above 120 packets a minute, which is extremely high. I mean, this is the default here is pretty much no limit at all, right? But if you wanted to say, I don't want to allow any more than 20 packets per minute and at most 40 packets per minute. So if something were to cause APRX to go start transmitting quite a bit, or if there was a lot of Digipeater requirements, after the first 20 packets, well, after 20 packets across it, it would empty out what's called a token bucket, where each time that each time that this transmits a packet, it debits 1 point out of this bucket, and 20 times a minute, or 20 tokens per minute are added back into the bucket. But that's only if you're really concerned about local channel loading, and so typically that's not necessarily required. Now we're up to source definition. So this is for APRX per Digipeater, you can define one transmitter, and then for that transmitter, you can have any number of sources that you want, right? And so the first source that we're going to want as a standalone Digipeater is going to be, again, this same interface of my call. So any packets that come in on my call need to be a source to go back out on my call. This is how you cause APRX to behave in this kind of mirror way that Digipeaters do, where packets come into it, processed, and or come out on the same channel. Relay type, you've got a couple different choices here. The two ones that would be relevant here are either digipeated or direct only. Direct only is another great feature supported almost only by APRX as far as I know, where instead of APRX looks at each packet coming in. Oh, really? I lost network connection? That's awkward. Let's recover. Okay. So anyways, sorry about that. Relay type is going to be direct only, which means APRX looks at each packet coming in and tries to make a good educated guess as far as, does it think that anyone else has digipeated this yet? This is a pretty effective way to act as a fill-in digi, where the only thing that you want to do as a fill-in digi is digipeat packets that haven't been digipeated by anyone else yet, right? So it's the first hop. This is not how APRS digipeaters typically handle this fill-in role. Typically, that's just by strictly following, only digipeating on the wide 1-1 alias. But that wide-1-1 alias thing was kind of really a hack for legacy firmwares, and we're not limited by that, right? Because we're writing, this APRX was developed post this idea. And so this direct, this fill-in digipeater concept is baked in. Viscous delay is another concept specific to APRX, where anytime that a packet comes in on this source before being transmitted, if it wants to, it gets put in this quarantine bucket for a number of seconds. So if we wanted to quarantine each packet for 3 seconds, it would hold it for 3 to 5 seconds because it adds another one or 2 seconds to this number, and it waits to see if there's any echoes, right? And so in a fill-in role where we only want to digipete it if no one else does, we then not only digipete on the first hop, but we could hold it for a few seconds to try and make the decision, wait and see if the nearby high-level digipeater actually picks it up regardless, and our digipeating is needed, right? At that point, it just drops the packet. It gates it, internet gates it regardless, and so this only impacts the local RF network. And so that can be a relatively friendly change there. And then you again can, if you want to restrict service areas or blacklist specific call signs, you can set those filters up here as well, right? And that's the end of the source block there. Now, if you had a second receiver with a high gain antenna pointed in a specific direction, you could set that up as a second interface block up above, and then here set it up as a second packet source into this digipeater. We don't want that, and I need to fix that. There's a missing comment there, but just make sure that that's all commented out. Right, so that would be if you had a diversity receiver, right? That's where that comes from. And finally, if we wanted to be an RF gate, which is the opposite of an internet gateway, right? Because the internet gateway receives local packets on your RF network VHF channel and puts it on the APRS internet system. RF gates take packets from the internet system destined for stations locally and transmit them out. You can also, this is how this is handled is heuristically it looks at the destination call sign on messages in particular, and then we'll route them accordingly. So you say for the source, instead of giving any of your interface call signs, you just say APRS IS, right, which we defined above. Relay type, you want to say third party. For RF gating, you can set up a viscous delay. So this is again, it holds it for several seconds, waiting to see if it shows up on RF regardless. But if you want to be the most authoritative RF gate locally, you can turn that off. Or if you want to, if you're setting up multiple different ones, you could tier them. So one of them has a viscous delay of 2 and one of them has 5, right? And this is all local network design stuff. And again, just to protect the local network in case someone's kind of going a bit nuts with messaging, you can set rate limits on there. And that's the end of that source block. DPRS is a different packet source that APRX supports, but I have to admit that personally I don't actually use or test it all. And that's the end of the Digipeater block. And that's it. All right, so that's the config for APRX. So just to review, going to the top, you define your call sign, you define your location, which I didn't fill in here. If you have an internet connection, you want to be an internet gateway. You set up your APRS IS block with your passcode, which you can get issued from me or any other APRS developer. You set which server you want to log into, which typically rotate.aprs2.net is a perfectly valid set of servers, which is all of them. Logging, the defaults are fine. I prefer to change my RF log one to just APRX in the APRX folder, just rf.log. Down here in the interfaces block, you define your interface based on whatever radio interface you have. In my case, I've got a terminal node controller on TTY-S0 at 9600 baud. It speaks KISS, and I'm okay with it transmitting, right? Beacons, whatever we want our beacon to be. So I want a beacon out on just the radio interface, although you can do both. I want this set of beacons to repeat every 30 minutes, and so APRX will take this block of beacon definitions here, right, these three, and it'll randomly spread it across these 30 minutes. So roughly every 10 minutes, it will beacon by these two will be just direct, so only anyone immediately nearby will hear it. This last one will go out with a path of wide 2-1. So we'll go through one Digipeater. If I knew the nearest adjacent high-level Digipeater, right, you could put its specific call sign there, right? So if you happen to know the nearest high level, put it there. And that's just generally a little bit better than putting a routing alias there. But that just depends on your local network and which direction you want to go with it, right? And then finally we have our Digipeater block, right? And so this is really into this transmitter. Where do we want packets to come from when they get routed here, right? So we want to route packets from our receiver back to our transmitter, and we want to route packets from the internet system to our transmitter as well. For only messaging services, you don't need to define any filters. When you're defining filters for the APRS IS block here, you do want to be very careful because you can relatively easily produce a tremendous load on the local RF network. And so I generally discourage you from really setting up filters unless there's like one specific internet only connected station or there's one specific object that you really want to make sure that any packets from that end up on RF. A lot of networks, a lot of areas tend to suffer from the fact that no one actually really looks at RF traffic so much as they just look at APRS.FI. And so these tend not to be so much as important anymore. You close each source block and then you close the Digipeater block, and that's it. So at this point, we can test the config by spawning a root shell with sudo -s. And then we want to do an APRX debug. And it's going to come back and it's going to say that it saw a configuration error. So what did I screw up? Source definition, returning blah, blah, blah. Error. Yeah, okay, yeah. So it puked on the fact that I haven't defined my location yet. But yeah, so you would check that. It would probably start up and start scrolling by with diagnostic information. You would hit Control-C to exit out of it. And at that point, you would hopefully be ready to get this going. So to have APRX start on its own, you would edit the etc default APRX file, and you would tell it, I would like you to actually start APRX automatically, like that. And then you could either reboot or you could say service APRX start. And APRX would then start, except that in this case it's not going to because I need to clean this config. That being said, we need to, this is assuming that I had actually set up that TNC with into the the radio and the TNC into serial port TTY-S0. But at that point, you'd be good to go. Like, that's it. As for other admin stuff on the this Linux instance, you would probably want to have, you could have any sort of remote way to get in, logging, right? Because in var log, hopefully now, yeah, we have this APRX folder in here. All your logs will show up. And there's all sorts of options you can do for it there. But that's it. So that's APRX in a nutshell. Real quick intro, but that should get you started. So I think that's going to be it for this video. Is we've got the Linux instance set up. If there's another video for this, it's going to end up being instead really wiring up the CDM 750 into the PK88, since that's a little bit different than the Cam Plus we did last time, and then final system checkout and see how it behaves. Thanks for watching.